अस्सलाम वालेकुम मैम।
अस्सलाम वालेकुम मैम।
यादें मगर इस बार
How are you, ma'am?
Assalamu alaikum, ma'am.
Assalamu alaikum students. How are you? Hope you're doing good.
अल्लाह का शुक्र है
We are going to start the lecture. First of all, you have to open the chat box and you have to write your full name along with your class and section, right? And if you have any question regarding lecture, you can ask me in a chat box. Okay? Are you listening me?
Yes, ma'am.
yes yes
Yes, ma'am.
Yes, ma'am, your voice is clear.
Yes, ma'am.
So class, we are going to start the lecture. This lecture is for grade 8. Subject is physics, unit 5, gravitation. The date is 7 December 2020, Monday. Learning outcomes. Gravitational field as an example of a field force. So students, after the end of lecture, you will be able to explain gravitational field as an example of a field force. And you can also able to solve the questions of exercise 5.2 and 5.3. Now, unit 5.
Ma'am, page number.
Unit 5, gravitation. We are going to start the topic, which is gravitational field. So class, in the
Ma'am, what
previous
is the
lecture, we have discussed about the law of gravitation, right? So what is the law of gravitation? It is every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. So if we consider a one body as mass m, and if we take the other body Earth. So according to the Newton's law of gravitation, what will be the formula? If we substitute the value, it will be F is equals to G M me by r square. This is the mass of any object, and this is the mass me is the mass of the Earth. We represent the mass of Earth with capital M, and in subscript we write small e. And r is the distance between the mass of the Earth and the mass of the object. And we always take the distance from the center of the two masses. It is also written over here that where me is the mass of the Earth and r is the distance of the body from the center of the Earth. Now come to the second slide. Gravitational field. So class, are you seeing the this is the picture of the Earth, and we present it with a capital M. We take the whole mass of this object, this is the Earth, and we present it with capital M. So these are the lines which are coming towards the center of the earth, and basically these are the gravitational field lines, the force of attractions that attract the object toward the center. We have represent these force of attraction with the help of a gravitational field lines, right? So a mass m creates a gravitational field in a space around it. So there is a earth. If I can explain again, this is the earth, this is the so this is the earth, the space around the earth, it has the gravitational field. They have the force of attraction toward the earth. That's why we have attracted toward the earth. Now, so class, in the figure, you have seen that there is one mass which we have considered as the earth, and the other one is the any small object. So if a mass m is placed at some point in the space, you have seen that the mass m is placed at any point in the space around the mass m. It will around the mass m. So this is the mass m which we present with me. This is the mass of the earth, and this is the mass which is placed at any point in the space. So they will experience the existence of the field in the form of gravitational force. Obviously, this small mass m experience the force towards the center of the earth, and this mass earth attract the
Ma'am?
object in this direction, right? Because they both attracted each other according to the Newton's law of gravitation. So there is a force of attraction between a mass m and also the mass of the earth, and the distance between them will be taken as r. This r is basically the distance of these two masses. The one mass is the earth, and the other mass is the me. So the weight of the body is due to the gravitational force between the body and the earth. So basically there is a gravitational force which exists between these two masses. All right. Then if you see this figure, the weight of a body is due to the gravitational force with which a earth attracts a body. Gravitational force is a non-contact force. So class, gravitational force is basically a non-contact force. There is no connection between a gravitational force to the objects. Because let's suppose if I place the object at some height, obviously there is no directly contact of this object with the earth, but with the force of attraction, it will be come in the downward direction. The example given in your book, for example, the velocity of the body thrown up goes on decreasing, while on return its velocity goes on increasing. This is due to the gravitational pull of the earth acting on the body, whether the body is in contact with the earth or not. Such force is called a field force. So class, let's suppose if I have any object and I throw this object in a upward direction. Obviously, this object will be go to some extent in the upper direction, and then it will be move in the downward direction with a very speed, because the force of attraction is always toward the earth, as the arrow is shown toward the center of the earth, right? So there, when I throw the object in the upward direction, there is a no contact of the object with the earth, but because of the gravitational pull, the object will be moved in the downward direction towards the earth. And these lines, the force that bring the object toward the earth is basically a field force. Then we have gravitational field strength. Gravitational field strength, the gravitational force per unit mass is called the gravitational field strength. This is the gravitational field strength. Near the surface of the earth, the gravitational field strength is 10 Newton per kg. Then now I explain how this gravitational field strength works. See, if there is an object at some height from the earth, obviously it will be attracted towards the earth in a downward direction. When it will be come toward the earth, obviously it will be moving with some acceleration, and there is a force of attraction that moves the object toward the earth. According to the Newton's second law of motion, force is directly proportional to the acceleration. But if you see over here, as the object is moving from to some height towards the earth, then it means there is a force of gravitation. It's mean that acceleration will be equal to the gravitation. Gravitation is also a force that attract the object toward itself or toward in the downward direction. Now, here the acceleration is equal to g because object is moving in the downward direction. Then we can say that the acceleration must be equal to the gravity. So I can write that F is directly proportional to g in the case when the object is attracting towards the earth in a downward direction. And according to the Newton's second law, the force is also directly proportional to the mass. If the mass is more, the force will be more, and it will be the object will be moved downward direction with a speed, right? So according to the Newton's second law of motion, if I write the exact form of Newton's second law of motion, it will be like F is equals to ma. ma, and here we have considered that a will be equal to g. So I can write it as mg. Now I have to find the this gravitational field strength, right? So I can write it like F by m, which is equal to g, because we are going to find the gravitational field strength. So I can make this formula. If I substitute the value in the formula which I have write, g is equals to, I can write again the formula, g is equals to F by m. So everywhere we know that the value of g will be equal to the 10, right? So I can say that there is a 10 Newton of force of attraction due to which the object will be attracted towards the earth, and the mass is always measured in the unit which is known as kg. So basically this is the force of gravitational field strength by which the object will be moved towards the earth. I can also write this equation as 10 Newton. Kg is in denominator, so I can bring it in, when I bring it in numerator, I will put -1 over here, right? So this is the gravitational field strength, which is also shown over here. So this is the gravitational force per unit mass. It is known as gravitational field strength, and it is its value will be remain same everywhere near the surface of the earth. Its value will be remain 10 Newton per kg. Yes, Abdullah, you want to ask something? Abdullah, you
ma'am,
can
I
ask the
wanted.
question.
Yes, ma'am. So you are saying that the
मैम ये कॉपी
formula
में
for.
लिखे
You can ask the question if you raise the hand.
Ma'am, do we have to write this? Ma'am? Ma'am?
Class, is there any confusion? If there is any confusion, you can ask the question in a chat box. Okay?
मैम
Ma'am?
do we have to write this मैम ये लिखना है
Excuse me, ma'am.
Ma'am?
I have raised my hand.
यार को
Ma'am? Ma'am, do we have to write this?
So class, this is your homework and you have to write these questions on your notebook. And these questions are from your exercise page number 115. The first
मैम यही है
question
बस
is, what is meant by force of gravitation? The force of gravity. Answer. There exists a force due to which every body of the universe attracts every other body. This is called the force of gravitation. And we have discussed the force of
Ma'am?
gravitation in the previous lecture, which is given by the Newtons, right? So you have to write this question on your notebook. Then second question is 5.3. Do you attract the earth or the earth attracts you? Which one is attraction with a larger force, you or the earth? We attract earth, earth also attract us. In the previous slide, if we go on the previous slide, we have seen that there is a force of attraction between the both objects. We are also considered as the object and earth is also considered as the object. So both have the force of attraction between them. So we can say that we attract earth and the earth also attract us. We both attract each other with the same force, but we know that attraction between two bodies depend upon their masses. Greater the mass of the bodies, greater is the force of attraction between them according to the Newton. So class, as the mass of the earth is very big as compared to us, so there is a more mass of the earth as compared to our mass. So there will be the more chances that earth will attract us. So if the greater the mass of the object, greater will be the force of attraction. So obviously the earth will attract us with a larger force. So class, these are the questions which you have to write in your notebook, and you have to do your work regularly so that you cannot face a problem when school will be open. So you have to solve these questions 5.2, 5.3 in your notebook. I will not give you much questions. I will only give you a few questions as a homework on a daily basis. So if you have any question, you can ask me.
Yes, ma'am. Can I ask a question?
Class, don't write irrelevant question in the chat box. If you have the question, you can ask me.
Excuse me, ma'am. I have a question. Ma'am, I wanted to ask. So you
So
were
class,
saying that the.
all of you have book with you. Now we will do a book reading. Okay. Take out your book and open page number. Open page number 109. All of you have book with you. Gravitational field. According to the Newton's law of gravitation, the gravitational force between a body of mass m and the earth is given by F is equals to G m me by r square. Class, do open page number 109. Okay. So the
109
gravitational force is given by F is equals to G m capital me by r square. We have used the Newton law of gravitation over here, and we know that the mass me is the mass of the earth and r is the distance of the body from the center of the earth. The weight of a body is due to the gravitational force with which the earth attracts a body. We know that there is a force of attraction that attract a body toward itself. And obviously, if the body has a weight, in this case the body will be attracted, because we know that W is equals to mg. When body has a mass and it has a gravitational attraction, then we have a weight, and due to weight there is a gravitational force which attract the object towards itself. Now gravitational force is a non-contact force. We have discussed in the lecture as well. For example, the velocity of a body thrown up goes on decreasing, while on return its velocity goes on increasing. So class, we have discussed in the lecture that as we throw the object in an upward direction, the object will be go to some extent and then it will become downward because of the force of gravity, because there is a gravitational force that attracts the object toward itself. This is due to the gravitational pull of the earth acting on the body, whether the body is in contact with the earth or not. Such a force is called a field force. It is assumed that the gravitational field exists all around the earth. We have discussed that there are the fields. These are the fields that exist around the space of the earth, and by which we can attract the object toward itself. This field is directed toward the center of the earth. The gravitational field becomes weaker and weaker as we go farther and farther away from the earth. So class, if we move away from the earth, obviously these field will be very less at some point. Like suppose if at some height, there will be a less we field forces as we increases our distance. The gravitational field become weaker and weaker as we go farther and farther away from the earth. In the gravitational field of the earth, the gravitational force per unit mass is called the gravitational field strength. We have discussed over here about the gravitational field strength. Gravitational field strength is basically the force per unit mass. At any place, its value is equal to the value of g at that point. Near the surface of the earth, the gravitational field strength is 10 Newton per kg. We also have derived how the value 10 Newton per kg comes. It's because of the Newton's second law of motion. With the help of Newton's second law of motion, we can calculate the value 10 Newton per kg, right? So this is the value of gravitational field strength. So class, this topic, I also did the book reading from your book. So if there's any confusion, you can ask me a question.
Ma'am, will you upload
Ma'am,
this
will you
lecture
post
on
the
GC?
lecture on GC?
Yes, Kashyap,
कॉपी पे लिखना है
what question you want
excuse
to
me,
ask?
ma'am.
कॉपी पे
Can
लिखेंगे
you
बस
tell me the exact formula of gravitational force?
Kashyap, you can unmute yourself. Now you can ask the question.
Ma'am, can you tell me the exact
Now,
formula
I'm
of
not hearing you.
gravitational force?
Can you?
Ma'am, we can hear.
Yes, Kashyap, what you want to ask? I'm not
Can you tell
hearing
me
your
the
voice.
ma'am? Can you tell me the exact formula of gravitational force?
Yes, Kashyap. Yes, Kashyap, please ask the question.
Ma'am, can you tell me the exact formula of gravitational force?
Gravitational force is basically the force which we represent by the F, right?
Excuse me, ma'am.
See over here, this is F is equals to GMME over R square. Yes, any other student? Who want to,
Ma'am, will you post the lecture on GC?
yes, I will post the lecture on GC. Any other question, class?
No, ma'am.
Okay, thank you. So class, this is the lecture for today. If you have any question, you can ask me. If not, you can leave the lecture, okay?
Ma'am,
Okay,
can you open
Allah
slide
Hafiz.
number 7?
Yes. Do you have any yes, beta, you have any question on this slide? These are, these are, these are the questions and answers.
No, ma'am, I just wanted to note down the question.
Beta, I will go to lecture on GC, so you can write the questions from on your notebook from GC, okay? So class, if there is no
Okay,
question,
ma'am.
Ma'am,
if there is no question, I will end the meeting and you can go
Ma'am,
to write these questions in your notebook, okay?
Okay, ma'am. Allah Hafiz, ma'am.
Allah
Okay,
Hafiz.
ma'am. Thank you.
Allah Hafiz, ma'am.
Allah